Good afternoon, my name is Artem Khovrat and now I want to present the results of study conducted by the Kharkiv National University of Radio Electronics, Lodz University of Technology and Karazin Kharkiv National University. Dual-layered artificial intelligence solution for classifying disinformation in socially oriented systems. The challenge of detecting fabricated information in systems with high user interaction, such as social media platforms, is becoming increasingly relevant in both academic and legal discussions. This growing concern is primarily driven by advancements in information generating technologies and the rising volume of information individuals are exposed to. In critical situations such as time of social upheavals, such misinformation can pose substantial risks to both individuals and society. When classifying text or data, three main approaches are typically used: probabilistic models, neural networks, and naive polynomial models. These may include techniques that employ convolutions with weighted coefficients and specific constraints. Previous research on binary classification of data into credible and fabricated categories has explored various probabilistic models in neural network-based algorithms. Findings suggest that a hybrid network, which combines recurrent and convolutional features known as RCNN approach, proves to be one of the most efficient models both in terms of accuracy and computational performance. While some texts may adopt a humorously exaggerated tone posing little threat and resulting in minimal societal impact, misinformation designed to destabilize significant legislative efforts can pose serious risks to societal stability. To reduce the amount of misclassification cases, it was decided to create a two-layer data classification model that, in addition to determining thickness, could also assess the degree of purpose of data falsification. You can familiarize yourself with the key tasks on the slide and also with the main sources of information to determine the specific issue in current domain. During constructing an appropriate model, the formation of a feature vector is crucial. To identify the influence of this news, we segregate the number of the features. Excessive use of rhetorical questions to distort socially significant information contextually, lack of negative constructions combined with the substitution of pessimistic terms with more extreme alternatives, such as replacing problem with catastrophe, inappropriate use of apples in incentives, excessive use of pronouns, and presence of grammatical and stylistic errors that may indicate the untruthfulness of the information provided if this is a quotation of official data sources. It's worth noting that these criteria are not exhaustive, however they serve as foundation for establishing targeted indicators which will be discussed further on. The first step of resolving multi-classification task is determine the main classes of disinformation. To determine this classification schema, an expert panel comprising 20 data analysts from various European and North American countries was assembled, ensuring geographical and institutional diversity. This systematic sampling approach yielded a comprehensive list of 10 predominant categories, which underwent further refinement through statistical validation. Following this, an open survey was conducted to identify the most susceptible types of information falsification. The aggregated responses from 300 participants were used to form these identified groups: jokes, strict jokes, subtle jokes, local news, regional news, and global news. Having identified the features of fake information, we can now move on to developing a set of characteristics that will serve as input values for models. The first such indicator is the emotional characteristic, which is derived based on the principle of content analysis. The general processing algorithm is as follows: clean the textual description from words without significant lexicographic load, create a dictionary of key lemmas and find the frequency characteristics of each word, determine of the polarity of each word and correct of frequency values, aggregate and further normalize of the obtained data within the range from 0 to 1, where 0 the situation has a negative emotional description and 1 positive. In addition to this feature, it was decided to consider 6 additional ones, which you can see on the slide. Rhetorical density coefficients, defined as the ratio of rhetorical construction to total sentences; negative construction frequency, quantifying negative linguistic structure density; contextual emotional index, derived from sentiment analysis of temporally relevant high traffic context; suspicion coefficient, computed through lexical pattern matching against predetermined deception indicators and a priori algorithm; message impact factor, a hierarchical classification of content significance and sentiment magnitude vector, an aggregate measure of emotional content intensity. The selection of the a priori algorithm is motivated by simplicity, ease of implementation, and ability to support parallel processing. The algorithm follows 4 key steps: generation of candidate item sets, pruning, generation of frequent item sets, and rule generation, where strong association rules are derived based on confidence thresholds. After addressing the key features, we can proceed to discuss the models used for classification. RCNN. This model combines multiple convolutional neural networks capable of operating in parallel with a bidirectional recurrent network that supports both short and long-term memory. This approach employs hyperbolic tangents and sigmoids, effectively addressing the issues of exploding and vanishing gradients by constraining the range of resulting values. Additionally, the defined model accounts for the entire historical context. The parameters of the model are shown on the screen. The essence of the naive Bayes classifier lies in applying Bayes' theorem to ascertain the likelihood of an observation belonging to a specific class, assuming independence among variables. The classical formulation of Bayes' theorem you can see on the screen, and to prevent numerical underflow for multiplying small probabilities, calculations are implemented in logarithmic space with feature weighted based on the information gain matrix. And formula you also can see on the screen. Last algorithm polynomial approach. The essence of this approach is to use convolution with weighted coefficients and set appropriate threshold values for each of the classes. The formula and result limits you can see on the slide. To enhance the speed of preprocessing, algorithm was opted to utilize MapReduce technology, which involves dividing the original dataset into separate nodes. Central to this approach are the mapping and reduction functions. In the Hadoop implementation displayed on the screen, a key feature is the repeated reduction of data within each node. Given the decision to process a substantial amount of external data, this strategy will further accelerate the proposed models. Let's move on to determine the experimental environment. After expert evaluation among several specialists in the field of data analysis from Ukraine, Poland, Austria, Portugal, and the United States, the following indicators were selected as the key performance criteria. Accuracy, defined via precision and recall matrix, with importance factor of 16, saving the time of the target algorithm with importance factor of 2. Saving the minimum permissible amount of target data to achieve accuracy of more than 80% with importance factor of 2. So the following formula can be approached for the effectiveness evaluation. Regarding the datasets, the research selected the full-scale invasion of Russia into Ukraine and false information during 2020 election process in the USA datasets. The described datasets were formed by the authors of the current work using the X social networks, Telegram, and other social networks from different parts of the web. On the screen there is a table presenting the normalized evaluation results of the target models. Here the RCNN, this is the use of basic model for multi-factor classification. As can be seen, the accuracy of all two-level models is significantly greater than the base model. At the same time, the best results are shown by combining several RCNN and RCNN plus NBC approach. The speed of all models is approximately the same, while the data requirement is the lowest in RCNN plus NBC approach. The calculation of linear additive convolution indicates that under certain conditions this model can be regarded as at least as effective as a doubled RCNN. These findings underscore the total effectiveness of two-layer models in comparison with basic approach for multi-factor fake classification. The study aimed to create a two-layer data classification model that, in addition to determining fakeness, could also assess the degree and purpose of data falsification, and the results show that each approach using a two-layer model achieved an average 20% improvement in effectiveness compared to the direct use of RCNN approach. In particular, the combination of the naive Bayes classifier and RCNN produced the highest efficiency coefficient. This finding highlights the potential of this hybrid approach for using high-load systems where quick identification and response to fabricated information are crucial, such as social networks. And you can see the list of used sources on the slide, and thank you for your attention.